So this is a problem of ISI PhD entrance exam 2024. This is a very interesting problem of finite group theory. So the question says that let G be a finite group such that for any two non-trivial elements x and y there exists automorphism phi of G such that phi x equal to y. Then we need to show that G is abelian. Okay. Observe that x and phi x both have same order. Since phi is a automorphism, right? That means if x to the k is 0 or x to the k is identity for some k, that means phi x power k is also identity, and since it is automorphism, so that means the order must be same. This will imply we have a given condition that any two non-trivial element there exists automorphism phi such that phi x equal to y. That means x and y both have same order. That means any two non-trivial element of G has same order, right? That means every non-trivial element has the same order, say k or say n, right? If n is not prime, p divides n, right? Then let n equal to pk. Okay. Then x to the k power p is identity. This will imply that x to the k has order p. That's a contradiction because we know that every non-trivial element must have same order. So since the order is n and p divides n, that means, and n is not a prime number, that means x to the k power p is identity, so x to the k has order p. But x to the k is also a non-trivial element, so x to the k must have order n. That will imply that p equal to n. That means n is a prime number, right? Hence n is a prime number, right? So hence n is a prime number. So now we have conclusion. G is a finite group such that each non-trivial element has order p, right? Then order of G must be p power m, because if there is some another factor in order of G, say q divides order of G, where q is prime, by Cauchy's theorem there exists G belongs to G such that order of G is q. But that is a contradiction because we already know that every non-trivial element has order p. That means G is the p group. G is the p group. Now we know important result. A p group has non-trivial center. A p group has non-trivial center, right? A p group has non-trivial center. Then choose an element x belongs to center of G such that x not equal to identity. We can choose that because it has non-trivial center, right? Okay. Now for any y G, there exists phi y such that phi y of x is y, right? I give it just a name. Since x belongs to zg, xg equal to gx for all g belongs to g, that will imply phi y of that will imply phi y of xg equal to phi y of gx. That will imply phi yx times phi yg equal to phi yg times phi yx. That will imply y times phi y of g equal to phi y of g times y. So hence y commutes with every element. This will imply y belongs to z, and y is an arbitrary element. This will imply it's a very interesting problem. So I hope you like this solution. If you have any doubt, please comment.